Alright guys, so just remember that problems like 1 and 2 are exactly what we covered last week. And it's just really just operations of functions. And the hardest thing about operations of functions is understanding what the notation is telling me to do. So if you remember, this is read as f function plus the g function when your input is 2. Now for some reason that doesn't make sense to me. I like to do it like what I like to say the common sense way. And the way I like to kind of analyze what this is telling me to do is I take that f function and I input a 2. So I'm going to find f of 2, and then I'm going to add it, because that middle operation is telling me to add, to g of 2. So for some reason, whenever I write it out, and I think that it's standard or common sense, it makes a lot more sense of what I need to do. I need to find what f of 2 is, so I need to plug in 2 into the f function. Then I need to add it to g of 2. So I need to plug in 2 into the g function. So let's do all that mess, but let's do it one step at a time. So let's find what f of 2 is. Here is my f function, here's my equation. I know that f of x is equal to x squared plus 1. That means that I can rewrite my function, but everywhere there's x's, I leave the parentheses, so that way I can input whatever I need to input, which in this situation is a 2. Now, I like to do one thing at a time, so I'm going to go ahead and simplify this one out. 2 squared is 4. When you add the 1, it equals 5. So I have found f of 2. F of 2 is equal to 5, and I'm going to add it to whatever I get for g of 2. Now, g of 2, your input is 2. You're going to plug it into the g function. Here's the g function. It's a little simpler. It's just 2 times whatever x is. And again, what are we inputting? We're inputting a 2. 2 times 2 is a positive 4. So you can see here that this one was a little more straightforward, which is nice. But don't forget that what operation are we doing in between these guys? We're adding them. So don't forget to add them at the end. 5 plus 4 is a positive 9, which I'm just going to write over here in red, which is 9. So f plus the g function when your input is 2 is equal to 9. Where I think the money's made is understanding the first step of what they're trying to tell you to do. And let's go ahead and do the next one. Now this is, again, a little more complicated for me to see. I like to write it out. This is going to be f of x minus g of x. Now keep in mind that what you're doing here doesn't really change. You're still going to take that x function, and you're going to plug it into the x input, and you're going to plug it into the f function. Now notice that when you input the x, you're going to get the same thing, because f of x is literally equal to what you got. So that means that I'm going to take the x squared plus 1, and then I'm going to add it, minus it, to whatever the g of x function is. And the g of x function here is a 2x. So you can see here that this one's a little bit, I wouldn't call it straightforward, but it's a little bit more kind of less work, less of the kind of the evaluating, because you're dealing with the variables. You just got to simplify. Speaking of simplify, let's simplify this. Remember that you need to combine terms when possible. Let's start with distributing that negative. We end up with x squared plus 1 minus 2x. Now, can we combine any of these terms with each other? The answer would be no, but we still have to have it in order from greatest to least degree. That means my x squared has to come first, followed by my linear, which is just a negative 2x, and then my constant, which is that positive 1. And that's all we can do pretty much for this problem. We're done. That was all review from yesterday. Or last week, right? So these are operations. You're minusing, you're plussing, dividing, multiplying. Now we're going to start the actual composition. Everybody get a chance there? Okay. So today we're going to start something that's called composition of functions. And in a composition, a function is performed and then a second function is performed on the result of the first function. Now that is a pretty mathematical thing to think of. What we're literally doing is we're taking an input, we're plugging it into an equation, we're going to get an answer out, and we're plugging that answer into another one. It's really, we're using an answer to plug it into another equation to get our final answer. Now a little more visual way of showing you exactly what you're doing here is, let's say that I give you some input, let's just call it x. I'm going to give you a function to perform it. So you're going to evaluate that x for that function f, and you're going to end up with f of x. And then you're going to take that answer and you're going to put it into another function to end up with your final answer, which is going to be g of whatever f of x was. So This is literally what a composition is. It's literally taking an input, plugging it into an equation, getting an answer, taking that answer and plugging it into another equation. It's just going over and over again. Now that isn't really hard. I have all the faith in you guys that you guys know how to evaluate. The hardest thing is understanding the notation, understanding what it's telling you to do. And that is what I'm going to try my best to get you to do, at least here and here. So you would think in a perfect world, if I gave you g of f of x, you would understand that it's pretty straightforward just to be like, okay, I'm going to take my input of x, I'm going to plug it into the f, and then plug it into the g. But when you're doing composition of functions, they're going to kind of give you a little bit harder time in terms of the notation. The way they're going to give it to you is they're going to tell you, they're going to give you the function, they're going to put an open circle to notate a composition, and they're going to give you your other function, put it in parentheses with an x. Now, again, why does the operations on functions and composition of functions kind of throw around this kind of confusing notation? And the answer is I really don't know. But what I do is I train my mind that when I see this, I'm actually seeing this, and I actually rewrite it. And this one's a little more straightforward because you just literally work backwards. You take your input of x and you plug it into the f function. You take that answer, you plug it into the g function. So whenever I see something like this, I just rewrite it. I say, okay, here's my x, I'm going to plug it into the f, and then I'm going to plug it into the g. And this makes a lot more sense to me. I don't know why. I feel like it's just easy to go from inside to out. But again, it's whatever you need in order to help you understand what the notations tell you to do. Okay? Make sense? Okay. All right, so let's get to an example here. So I know that this is a composition because it has that little open circle. Whenever you have that open circle, it's literally telling you to do a composition, to plug something into something else. And you got to train your mind because, of course, I think this is the first time you've done. I think this is an Algebra 2 standard that you get at this level, not anything before. So this, for some reason, doesn't make that much sense to me of what the problem is telling me to do. So I always like to change it to the kind of what I like to call common sense. And I do it by working backwards. I take that 2 and I'm going to plug it into the g function. So what you're literally going to find is just g of 2. Whatever that equals to, whatever g of 2 is equal to, you're going to plug it into the f function. So that's what I literally do. Take the input, parentheses, g, parentheses, f, and then all of a sudden, for some reason, this makes complete sense to me. I know I'm going to start off with plugging a 2 into the g function. Well, let's go ahead and do that. Here is my g function. In order to prepare it, I'm going to rewrite it with open parentheses everywhere there's an x. And I'm going to go ahead and actually input the 2. Now, g of 2 is what I'm looking for. This is what it's equal to, so we have to kind of go through the math, right? Let's start with the exponents. 2 squared is 4. Don't forget to add 2 minus 1. There was nothing to distribute, so I just kind of dropped the parentheses there. 4 plus 2 is 6. Don't forget to minus the 1, so it equals 5. What does g of 2 equal? 5. Now, remember, what were we going to do with g of 2? What are we going to plug that guy into? The f function. So here is my f function. Let me change colors so that way you can kind of see that I'm working with 2 different equations. F of x, right over here, f of x is equal to x plus 3. Again, everywhere there's an x, you're going to leave an open parentheses and plug in whatever your input is. And remember, you found g of 2. You know it's equal to 5. So all you need to do is plug in the 5. Now, luckily for us, this is a pretty simple one because it's just 5 plus 3. 5 plus 3 is 8. That's the end of the result because you got your original answer, you plugged it into another equation to get another answer. So you can kind of see where I mean by like Inception-ish. Not really, right? Not as entertaining as this. All right, so try number 2. Keep in mind that it's very similar, but you got to make sure you understand the notation and see how it works. I'll pause this real quick and I'll walk around and see if I can clarify. We'll go over it. Only a couple more examples today. You'll have a lot more time for homework time. All right, so let me go from this one from beginning to end. So the main thing here is that you're understanding here that you have a composition. So what you're really doing is you're taking an input, you're plugging it into an equation, getting an output. Then you're taking that output and you're inputting it into another equation to get another output. Now, if you look at this notation here, it pretty much tells you what to plug in what moment of time. So we're going to start with the 2 and we're going to plug it into the f function. So that is literally just f of 2. Now, after you find f of 2, you're going to plug it into the g function. So we're going to take that answer and plug it into the g function. So that alone, if you can get what it's telling you, that's the huge giant step, probably 60% of the problem. The other 40% is actually doing the math. So let's go ahead and do that. Let's take that 2 and plug it into the f. Now looking for my f functions right over here, that means I'm going to take that f of x, and everywhere there's open parentheses, I'm going to input whatever I'm inputting, which in this situation is 2. Now f of 2 is what I'm looking for. This is what it's equal to. 2 plus 3 is 5. So that means that f of 2 is just a positive 5. Now, we're going to take that f of 2, and we're going to plug it into the g function. Now, here's our g function. So it's going to be g of whatever x is going to equal whatever x is squared, plus whatever x is minus 1. All I did was rewrite my g function with open parentheses where there's x's, because I know that's where my input goes. Now, remember, you're taking the answer of f of 2, which is 5, and you're plugging it into the g function, and now you just got to figure out the math. Start with the exponent 5 squared is a positive 25. I'm going to drop these parentheses because there's nothing to distribute. And now I could just do the addition. 25 plus 5 is 30. 30 minus 1 is 29. So you have finally ended up with your final solution, which is a positive 29. What do you guys feel? You guys doing okay with these? Yeah. You ready to bump it up? All right, what do you guys think? You guys think you guys have had me enough? What do you think is next? Huh? Wouldn't it be multiplication? Think of input. I gave you a number. What do you think? What else is missing? A variable. So notice that I gave you 2 brand new functions to work with. And now I want you to do the same thing, but now the input's a variable. Now remember, conceptually what we're doing is we're taking an input, plugging it into an equation, getting whatever that output is, and plugging it into another equation to get another output. Now just because this input's a variable, are you really going to let that scare you? No, don't let it scare you. This literally is telling you that, hey, take that x and plug it into your g function. Once you figure out what that is, let me rewrite that to make it look a little nicer. You're going to plug in that g of x into the f function. So you can see here that you're not doing anything really different. It's just, of course, you need to change your mindset because you're dealing with a lot more variables and simplification. You're going to take that x, plug it into the g. When you figure out what that is, plug it into the f function. That's literally all we are doing here. Now let me show you what that looks like. I'm going to plug my x into my g function. Here is my g function. Everywhere there is an x, I'm going to leave open parentheses to plug in whatever I have. And you notice that while I'm plugging in this x, nothing really changes. And I'm not going to expect you to do this step that I'm doing. But the reason I'm doing it is to kind of show you that, hey, if this is an a, if this is a b, if this is an a plus 1, you're still going to input whatever you've got. Just make sure that you understand that if it's just an x, I'm totally okay with understanding, hey, g of x is equal to the equation. You don't have to plug in the x just to simplify it. But if you have an x plus 1, that's going to change things. All right. We know what g of x equals to. It's equal to all this stuff. What are we going to input that into? The f function. Where's your f function? It's here. F of whatever x is going to be equal to whatever x is plus 3. Now remember, you're plugging in g of x. What is g of x equal to? Hopefully everyone's saying x squared plus x minus 1 because it's literally just my really equation. And now you just got to simplify your life away. Notice that there's nothing to distribute, so I'm just going to rewrite it over. And then I'm going to go back and see, is there anywhere I could combine like terms? And which one of these terms can you combine? The constants, right? Yeah, exactly right. Yeah, the constants. So notice that this is the ugliest looking x that I've seen. Let's try to make it a little nicer. We end up with x squared plus x. Negative 1 plus 3 is a positive 2. And now you are done. You have now found your final answer. You've plugged in the input of x into the g function, and you plug that into the f function. And you can see that these problems are a little more kind of not as crazy tough type of thing. Does that make sense? Ray, try one more and we'll call it a day. All right, so try number 4. Go around helping people. Don't worry about these guys. Just worry about this guy and then we'll call it after that.